Hi everyone, Stephen from Audio Nordica here. I've been away for a month or so in the UK, and while I was over there I picked up this quad amplifier 405-2, and so I brought it back in my luggage. It's reasonably heavy but quite small. I bought it on eBay and it's advertised as having a dead channel. So I haven't done anything with this as yet. I haven't plugged it in. What I'm going to do first is I'm going to inspect it inside just to see if I can see anything obvious visually before I start to test it. So let's get the covers off this thing and see what we can find. Okay, so I've got the lid off this thing now, and just sort of familiarizing myself with the layout. So we've got two amplifier boards. There's one there and there's the other one there, and what I can see straight away, this amplifier board here, the fuses are out. So that pretty much tells me that this is most likely the dead board. I can also see that one of the front panel screws is loose, so possibly someone's been in there. I can also tell that it has the original electrolytic capacitors, so at some point I'll measure those to see what they're like. If they meter okay, I don't think I'll replace them straight away, but there's a good chance I will need replacing. So basically power comes from here. So this is the plus rail, this is the minus rail, and this is the ground. So we can just see that going to the board. There's the ground there. Here's the red wire is plus, and the black wire is minus, and the purple wire is the output. And so the same on the other side. And then this screen cable here, that's the audio in. So very, very simple. So what I'm going to do now is, given that those fuses are out on that second board, I'm going to take a bit of a leap and put power on this and see if at least one channel is working, because then if I can prove that this board is okay, then it gives me an A-B comparison to then dive in and see if I can easily work out what's wrong with this board without having to get too tied up on schematics. So I've got a speaker connected to, I guess this is the right output because this is around the other way, and I've got audio. I've got a function generator here on my iPad, just making a sine wave. I'll just make sure that's still working. Yep, it is. Plug that back in there. So let's now leap in and do the smoke test. I'll just turn the volume down and let's just see what happens. Wow. So that is definitely coming from my test speaker, which I haven't actually taken out of the box, but that's all that we need to prove that that works. Okay. So I can hear there's quite a bit of noise coming out of this speaker. So you can probably hear that. I'm sure that that's not right, but that's okay. It's amplifying is the main thing, and who knows what the state of these capacitors is. So I think the next step is to dig a little bit deeper and see what we can find. Okay, so I've decided straight away to just test these capacitors. So the capacitance is reading okay, but the ESR is really higher than it should be. A typical table, 10,000 mic 63 volt should be less than 0.01, so this is 0.06. And we'll check the other one. Again, 0.06. Capacitance is okay. So we will be replacing those. I don't think that's what's causing the noise. There's probably some, if this thing is original, we'll know when we get it apart. But if there's some dodgy capacitors on these boards, then that's probably causing that noise that we're hearing. So let's get these boards out now so that we can have a closer look at them. Okay, so I've got these two boards out. Easy to get them out, it's just 4 screws. It's nasty, messy thermal paste. These look like they're in original condition. I can't see any obvious signs with an initial glance that they've been fiddled with, which is really good because this is what I was looking for. I wanted an honest, genuine, original unit that could, if need be, refurbished. And obviously this one with the dead channel, I knew that it would need something done to it. But the two boards, they look the same. They're the same model number. M12565.6. I haven't checked the service manual just to see exactly where that fits in the scheme of things. But they look to me like they've got all the original parts in them. So certainly these electrolytic capacitors are known to give trouble. So certainly those 1, 2, 3, 4 capacitors are going to need to be replaced. Also on, this is the dead one here, it looks to me, I haven't measured anything out yet, but this capacitor here, see there's a dark mark on the bottom of the board underneath it, and you can also see around here, see the dark mark in the fiberglass. It looks like it's gotten really hot just there. So whether that capacitor has died or something else has happened to cause this board to be dead. I mean, given that it's got the fuses out, that indicates to me that it's blowing fuses, and again I haven't metered anything out with this or done any testing on this board at all. But I think I'd put money on that if I were to put the fuses in and turn it on, it'd just blow a set of fuses. So there's a few things there initially to be looked at, and then as I do some more poking around, who knows what else we'll find. Okay, so this is why having an A-B comparison in terms of one dead channel and one not dead channel is so helpful, because it allows me to narrow down, just get an idea where the problem is. And pretty quickly I can tell by buzzing them out that there's some fairly critical differences. So just with my continuity diode checker, these are the driver transistors on the working board, and these are the finals. And if we go to the dead one, we can see that it's rather different. So that suggests to me that either the driver and or the final transistors are blown on this board. So the way to confirm exactly what's blown will be to take the transistors out of circuit and test them. So let's do that. Okay, so I've got the driver transistors out. I already had a little cheat with the multimeter and did not see a short circuit across them. So I'll test them with the transistor tester, but I expect these will be okay. Gain is 112 on that one. And this one, gain is 72. I don't think it matters that much that the gain is different. But those seem to be okay. So I think what that tells me, and we'll confirm this in the next step, but I think what this tells me is that this unit has got blown finals. So let's pull them out and confirm. Okay, so I've got the finals out of this thing now. Let's see how they test. Resistor, 0.18 ohms. I don't think it's supposed to test as a resistor. Test the other one. Start. Resistor. Yep. So that's not too surprising. So our two finals on this board are dead. Looks like the driver transistors are okay. I've just shoved them in there for now so that I don't lose them. It's always good practice to put things back where they come from. These are the same type, but I got to clean up all of this heatsink stuff, so that's why I haven't bothered soldering them back in now. And I may decide to replace them too, I don't know yet. But certainly I think really on this unit as a minimum, certainly these need to be replaced. These 5 electrolytic capacitors will need to be replaced. I need some new fuses. Need to check what this is here. It's a capacitor of some sort, whether it should be replaced or not. And also, as I mentioned earlier, these 2 capacitors here. So what I need to do now is sit down and do a bunch of research as to what I need for a DigiKey order. Okay, so I've cleaned up this board. Every time I picked it up, it's picking up heatsink compound from the back of this thing, so I've cleaned that off. And this little copper bracket here is just held in by this screw here, which is also the earth connection. There's no heatsink compound between it and this bracket, but it's still good to clean that up. So I clean that all up, and also this heatsink, it sort of continues out to serve the driver transistors. So as you can see, I've put the driver transistors back in, the original ones, cleaned all the heatsink compound off those as well, and I put in these nice sill pads. So no mucking about with heatsink compound. The thing that's really important to notice, and it's really important if you've not changed over these kinds of devices before, is that the case on both these two TO220s and also the TO3s, the case forms part of the electrical circuit. So if you just connect the case to the heatsink, then you're basically shorting out parts of the circuit. So there are little plastic insulators inside here. So there's one in each of these holes, and there's also in here as well. So it means that the case is not electrically connected to the heatsink. So I can just show that. So you see that that tab is not connected to the heatsink, but this pin here is the heatsink. That's not connected to there. Of course, you know, if this plastic sleeve wasn't here, then that would be a short. So you know, if you were to take these out, or they were to fall out and you didn't notice, then you'll end up blowing something up. It's very, very easy to do. So don't do that. So I've placed my DigiKey order, and I'll be back when those arrive. But just to show you what I have ordered. So mains fuse, that's this fuse here. It's always good to have some of those on hand. This one's fine, I haven't blown it up yet, but if something were to go wrong, then I'd be stuffed because I haven't got any. So that's why I'm ordering some of those. Ordered the main filter caps, so that's these guys here. So I'm replacing them with a 15,000 mic part. The current ones are 10,000 mic, and so this part is a Kemet part. 4 amp fuses, so I actually already have some of those. I found them in my junk box, so I don't need to actually purchase any of those. Then we have the op amp here. I'm going to replace that with a modern low noise part. So this one's currently not socketed. I'm going to put in a nice machine pin socket. So I'll just get a dip 8 socket, and I'm going to replace it with a TLE 2071 CP. That's still a Texas Instruments part, but it's a modern low noise replacement. Then the final transistors, because that's the part that's blown. Those RCAs obviously are no longer available. I didn't point out earlier either, the date code on these is really helpful for dating this unit. So 8245, 45th week of 1982. So this unit would have been built in 1983. The date code on the other board is the same for the finals, so that's encouraging. I think that they were both built at the same time rather than, you know, grabbing boards off the shelf, which happens sometimes. So I did some research, found a Quad 405-2 page that indicates that this on semiconductor part, MJ 1500 3G, is an equivalent replacement, so I've ordered 2 of those. They were about $11 each. The filter capacitors are about $15 each, so it starts to add up pretty quickly. I have ordered some driver transistors. I am not planning to replace them. As you can see, I've already put the old ones back in, but I thought it was a good idea just to have some on hand. And then the capacitors. So these Nichicon Muse bipolars, that's a 100 mic 10 volt part. That will be this one here and this one here. So Nichicon Muse bipolars. And then the other electrolytics, so that's these 1, 2, 3, 4. I'm going to replace those with Elna Silamec 2s. And so the part selection really is just based on voltage and size. These Elnas are a fairly similar diameter in the sizing. So I've just selected these parts here as being the closest sort of like next voltage up in sort of like modern voltage specs and a similar size, so that they will just fit nicely into those spots. So those are the parts that I've ordered. I think it was about $82 Australian worth of parts. So you can see the parts really do add up pretty quickly. Fortunately, freight these days with DigiKey is free, but it's still $82 worth of parts. So hopefully that will be all that is needed. So I've ordered enough capacitors to replace the capacitors on the working board, because they really do need to be replaced. And fingers crossed that with those parts, that will get this unit going. So let's wait for the parts to turn up and then let's dive into it. So my DigiKey order is here, so that means that it's time to dive in and get these parts changed over. Okay, so it's kind of been 2 steps forward, 1 step back on this thing, but we are making some progress. So I've got the new finals installed with their sill pads, and well and truly metered them out. I mentioned before there's these insulators, here and here on these case screws, because you don't want the case to short to the heatsink. So verify that those and also these are not shorting to anything that they shouldn't be. So that all looks okay. And I've got the new electrolytics in. These brown ones, all of them metered as bad, every single one of them. No capacitance. Also this black one as well, metered as dead. The only one of these 6 that made it any good was this blue one, which I've replaced anyway with one of these Nichicon Muses. I've also fitted an IC socket and fitted a new op amp. There's the old one there. I'm assuming the old one works, so I might be able to do some A/B comparisons. I'll decide later whether that's worthwhile. However, I did make an error in ordering the parts, in that one of these it's this one, C17, 10 microfarad 40 volt. It's actually bipolar, so I can't use the part that I got in. So this part is wrong. So I've had to order in a bipolar for C17. Basically, it forms part of the protection circuit, so it's not actually used for audio purposes. Here's C17 here, and it basically controls this triac arrangement, which is basically output protection. So it doesn't need to be a super duper high grade audio part. So I've had to order that part, and then coupled to the frustration, I then had to do another order. This is where these things sort of add up. I mean, this is my amplifier for me, so it doesn't matter that much, but if you were trying to actually make money out of this, you know, it's time and money every time you've got to do an order and freight. So I thought while I was waiting for that capacitor to turn up, I'd fit my new bulk capacitors. And as you can see, they are quite different in size. These ones are much smaller physically. And I hadn't really looked that closely at the dimensions. I knew they were smaller, but I didn't look close enough. And I'd assumed that I would be able to reuse the old mounting clamp to mount the new capacitors, but no way. So I've had to order 2 new clamps as well to be able to mount these. So those will actually probably turn up sooner than the bipolar caps, because I ordered these from DigiKey, whereas I ordered the caps from Farnell. So I ordered some caps from DigiKey as well, because they'll probably turn up sooner. And a couple of other bits and pieces from DigiKey as well that may come in handy. But I did check the dimensions, and on the chassis, the bottom of the chassis where these are mounted, there we are. So it'll mount into this one, and you can see that it was there, but there's also this hole here. So this hole will fit perfectly the bracket for the smaller capacitor. And we can see the same deal over here. It'd be this screw here, and that was the old bracket, and this one will be for the new bracket. So basically it'll just fit in there without having to drill any holes or bodge anything, which I really don't want to do. So anyway, now that I have got these new capacitors, I tested one of the old ones before. We'll just do it again, just to compare these two, now that they're out and nice and accessible. Okay. So that's 0.03. I'll just try the other one, because I thought it was worse than that. That one's actually measuring better. So that's actually pretty good, because that one's testing fine. This one's testing a bit higher. Yeah, it's 0.02. I'm sure it tested higher than that the other day. But look, now that we've got these things, especially given how much they cost, yeah, so it measures about the same, 0.02. But we do have higher capacitance on these new ones. They're 15,000 minus 20 plus 20. So that one's measuring about 13.5. And this one, 0.02, same ESR. And 13,800. So look, if I didn't have these new ones, I'd probably be happy enough to keep using these ITTs. They're not measuring that badly, but for the sake of the fact that we do have the new ones, we'll use those. So let's get back to waiting for parts to arrive. Okay, so my second DigiKey order's turned up with the bipolar 10 mic capacitors that I need, and also the mounting brackets to put in the new capacitors to replace the old ones. So as you can probably see, the new capacitors are in with the new mounting brackets, and the rebuilt circuit board is in as well. It actually goes around the other way. This is the way that it was in when the unit came to me, but this actually goes down the bottom. But I just put it back in the same way because it's easier to have these bits on the top for now. And I haven't put thermal paste onto the heatsink either, so it's going to have to come back out to put thermal paste on, but I wasn't going to put that on until I'd done some testing. Also, given what I found with the state of the capacitors, I wasn't too keen on powering up this working channel. It didn't sound all that crash hot when I initially tested it, so it certainly will need rebuilding, and you know, these capacitors will all need to go. So I've just left it out, and it's not hooked up. So at the moment we're testing the one channel that I've rebuilt. So if I put input onto that one, you can hopefully hear 1 kilohertz. And if we have a look at the scope, we can see 1 kilohertz on the scope. So that's looking really, really encouraging. That's looking like that channel is working the way it's supposed to work. I haven't done any in-depth testing in it because I want to get the unit properly back together rather than having bits and pieces hanging out of it. Is always a little bit fraught when you've got live voltages and so on floating around. But this board looks, which was completely dead, you remember it had blow-on finals, all the electrolytics in it were basically no good at all. So this board that was dead is now working. So now I'll get stuck in and rebuild the other board. So I'm just working my way through cleaning up all of these components on this heatsink on this second board. This is so that I can put in sill pads for these active devices. So here are the original driver transistors. They look absolutely disgusting. They've got rust on them. Looks like someone's soldered something to them at one point, but they test okay. So I'm going to reuse these because they are the original output devices. And then the driver transistors, they test okay as well, so I'll reuse those. So I'll remount those using sill pads. However, in taking this apart and cleaning it all up, I discovered something quite interesting. There's this little bracket which mounts here. Now, I mentioned on the other one, when I pulled it off, there was no heatsink compound between the bracket and the heatsink. And I'm sure it was like that as built because it's all the original devices. There's no reason for anyone to have taken it apart. But when I've taken this one apart to clean it, there was all heatsink compound on all the faces of this heatsink and on here. So I think that's how it's supposed to be, and for whatever reason when the other board was made, no heatsink compound was put in when the bracket was put in. So what that means really is that I'm going to have to unmount the drivers and the final transistors again on the other board and take it all apart again, so that I can put heatsink compound on these faces on the other board that I've already rebuilt, which obviously is a real pain and I don't want to do it, but if you're going to do a job, you might as well do it properly. So that's what I'll end up doing. Okay, so I've rebuilt this second board now. This is the so-called working channel. So I tested the final transistors and they're fine. I tested the drivers, they're fine. They've all been remounted on these sill pads, thermal compound underneath this copper bracket. I've still got to do that to the other one yet. New op amp chip, and then 1, 2, 3, 4, 5, 6 new electrolytic capacitors. So I tested the ones that were in it, and yeah, they were pretty sick. The only one of them tested as completely dead. The others had some capacitance, so just enough capacitance for it to kind of work. But yeah, they really needed to be replaced. So I'm now going to reinstall this board and test it and see how we go. Okay, so the other channel is now installed. There we are. So we put our 1 kilohertz on. That seems to be working. Okay, this thing's all cleaned up now, heatsink compound tidied up, and I've got a new bit of test gear here that turned up during the week. This is a Keithley 2015, 2015, I don't know what you call it, but anyway, it's a bench multimeter, but it also has a separate board, which is a fancy signal processing board, and a very accurate sine wave generator for measuring THD. So I got this thing primarily so that I can do some comparisons between gear. The comparisons mean a lot less than one would think. I'm not really into, you know, chasing THD. Amplifiers should be about what sounds good, and you listen to an amplifier because it sounds good, not because it's got good specs. I mean, this was the craziness that came in the 1980s when people used specs to sell amplifiers, and people bought them because of the specs on a piece of paper, not because of how they sounded. But nonetheless, anyway, this will still be something interesting for me to do, and do some tests across various amplifiers and see what sort of differences that we do get. So this is the first one that I'm doing any testing on. There's a few YouTube videos out there of people using this Keithley to test THD, and but there's one little caveat that I came across in reading the manual in detail that I didn't see noted on any of the videos. So I'll note that in a second. But firstly, I'm just going to write this figure down. So this is 500 Hertz. And I've set it so that at the speaker output I get more or less about 5 volts peak to peak. It's just above. It's just so that when I test different amplifiers, I'm more or less testing them the same way. So I get a THD of probably about, I don't know, I guess we'd call it 0.012 or so. So the default number of harmonics for this thing is 2, and to measure up to 20 kilohertz we want to take up to 40, because our frequency is 500 Hertz. So we can just change that here. Upper harmonic default is 2. Change this to 40, which should be 20 kilohertz, which is as high as it goes anyway. And there we are. So we had about 0.012 was our reading when we were just taking the second harmonic. Now we're taking theoretically all of the audio harmonics, and our reading's about, say, 0.031. So there we go, that gives us some baseline readings, and it'll be interesting to do some comparisons later on with some other amplifiers. So now we'll do the final listening test on this Quad 405-2. So thank you so much for coming along with me to get this amplifier back to life and working. I hope you've enjoyed it. If you have, please give me a thumbs up and subscribe to my channel, and I love to read your comments. And I look forward to seeing you on the next one. Bye for now.